All right, we are going to finish up what we started yesterday. Let's review just briefly, just so that you remember, because we're going to do a couple examples with these things. So let's put a circle here. Let's put a center. That's where the center is, right there. All right. And if we had a couple radii, one here and one here, we had a couple names for this. Let's copy and paste. Let's put this over here. All right, so let's just do this first one right here. Remember what we did yesterday? So watch. See that, and this. We had a name for that. All that stuff in here. I'm not going to... It's good enough. Don't have to do it all. What do we call this part? It's a sector. That's correct. Okay, it's a piece of the pie. All right, so this chunk of the pie, if people are... I saw a thing on Facebook or something the other day, and somebody took a piece of the pie, like from there to there, right? And said something about the husband did it on purpose to drive the wife crazy. Can you imagine somebody cutting out a piece of pie like that? Wouldn't that drive you crazy? Yeah, it would me. It would me too. So that would not be the piece of the pie, but this would be a piece of pie, right? You get a pizza, they slice it up, right? You get a slice of pizza, or a apple pie or cherry pie or whatever. So that would be a sector. Then we did this. We said, what if we connected where those two radii hit the circle? And now we're only going to talk about this little chunk right here. I guess you could cut out a piece of pie that looks like that. But again, that would be crazy to do, wouldn't it? So I'm in the middle of something. So if that's a sector, we call this the what of the circle? A segment of the circle. Okay? So that's a segment. You see the difference? All right, so we're not using all this stuff. We're just using this. What if I knew the sector, but I wanted to find the area of that triangle right there? Divide it? So what if I knew the sector and I knew the segment? What would you do? Subtract, that's right, okay? I mean, because the sector is the whole thing, right? The whole piece of pie. This is just a little bit of it cut off. What's left over, you subtract, okay? So that could be helpful at some point. Let's see. I think that's it for that. Now, they give you an example. It's not exactly with the sector and segment thing, but it just seems like some kind of random example they throw in here. I'll put it in there. I don't know if they give you homework problems with that on there or not, but we'll do it. It's in my notes. It's in the book, so let's do it. So example 2. So I've got another circle, of course. And I'm not going to necessarily... This is not necessarily drawn to scale, but that's okay. We'll say the center's right there. Put a little sliver right there. Put a little sliver right here. Okay? Now, they're going to tell you something a little different than they told you before. They're not going to tell you the actual angle. They're going to tell you, see this piece of pie right here, that sector? Okay? They're going to say that that's 45% of the whole entire circle. Okay? Then they're going to say that this little bit right there is 5%. Again, it's not necessarily drawn to scale, but it's close enough. This is 20%. This is, not degrees. What am I doing? 20%. And this is 30%. All right? Everybody see that? So what we're going to do, I don't know why I put it so close to the angle. Maybe because I was thinking ahead to put stuff where the angle is. I'm just going to put it just somewhere inside of there. Whoops, I missed a part. Slide that over. There we go. And one more. And put that up here. All right, that's good enough. wasting too much time on that nonsense. This is example 2. It says right there, example 2. Thanks for watching. All right, so what if I ask you to find the actual degree angle? What if I ask you to find that actual degrees? How many degrees is that angle? How would you do it? How would you do it? Don't give me numbers. I said, how would you do it? This angle right here. What if I wanted to find that exact angle, the degree of that angle? Somebody else. Close. Got half of it. It's not 45 divided by 100. Subtract what? Times 100? Are we just saying things? Let's have an educated guess instead of just a guess. What's 360? The whole entire circle. That whole thing is 360 right there. It's 45. You were onto it. Okay, it's 45% of 360. Very good. 45% of, what's of in multiplication? Oh, I just gave it away in math. It's multiplication. 45% of 360 degrees. It's not half. What percentage is half? 50. What's 50% of 360?
180.
180. Very good. It's half of 180. Agreed? So this is going to be a little bit less than 180, isn't it? All right. So how do I do the actual math, though? Percentage. I want to take that percentage and turn it into something. It's a decimal. What would it be as a decimal? 0.45. It'd be 0.45 times, I'm going to put a parentheses there so I don't get my decimals and multiplications mixed up. So what would you do? You just stick that into a calculator, okay? 0.45 times 360. I've already done the math for you. It's 162 degrees. Everybody see that? Okay. Does it make sense on why you do that? Because if it was 50% of 360, it would be what? 0.5 times 360. What's 0.5 times 360? It's 180, okay? Because we know 0.5 is a half, and we know half of 360 is 180. Agreed? Yeah. So it's the same thing with these different percentages, except it's not 50, all right? 50 makes sense in our head. 45, not so much. Now, what would I do with 5%? I would go what? 5% times 360. But what's 5% as a decimal? 0.05. That's right. So it'd be 0.05 of 360. And that is 18. All right. Let's do another one. The 20%. What's that as a decimal? 0.2. Okay. Or 0.20. It doesn't make any difference. Of what? 360. And that would be 72 degrees. And we got one more, right? 30%, which is what? 0.3 times 360. And that gives you 108. So this right here is 162 degrees. This right here is 18 degrees, this angle. This angle right here is 72 degrees. And this angle right here is what? 108 degrees. If I did it right, what should be true? What should happen if I add up all of those angles? They should add up to 360, not 160. 360. They should add up to be 100, or now you got me saying it. They should add up to be 360, okay? I didn't do that, but I assume that they do. So you could check that if you want. Okay, good. Everybody go with that? Yeah. All right. Let's do, we kind of did this already. Remember we found the length of an arc? Yeah. Didn't we? Did we do it in here? I'm trying to think. I don't think we did it in here because I think it was in my honors class. We talked about the length of the arc. Did we do that in here? I don't know. The length of the arc is equal to theta over 360. No? Not ringing a bell? Right. We didn't do this? Okay. I'm getting, because you're actually, listen, this is actually good for you guys. you're actually fairly close to what the honors class, where the honors class is now, okay? Because they are just, what are they on? What chapter is this? 7? They're on chapter 8. And, oh, I see. Okay, now I know why. So 7.6, this is just about circles. This is the first time we've learned about circles, isn't it, in this section? Chapter 8, the whole entire chapter is about, what do you think? About circles, okay? That's what was getting me confused. I was like, I can't remember which class I taught what. So anyway, let's just do this. I'll start from scratch. So what we're going to do right now is actually pretty helpful with what we're going to do in chapter 8, because chapter 8 is a whole entire chapter just about circles. You thought one section was enough of circles, right? But no, we got a whole entire chapter about circles. So let's do this. Yes, absolutely. What is the area? I'll put a little C right there. What do you think that C means? Area of a circle. I think we've already discussed this, haven't we? Did we? Yeah, we did this yesterday. First thing we did yesterday. We talked about the circumference of a circle. Now we're going to talk about the area of a circle. We talked about that yesterday. What is the area of a circle? Do you remember? Look in your notes. Should be pi r what? Squared. Good. All right, that's something you need to memorize. Absolutely, 100%. You need to know that. You probably knew that when you were in 5th grade. My guess is when you were upper elementary grades, they probably talked about the area of a circle and circumference of a circle. They probably, I know they didn't get into it near as much as we're going to eventually get into it, but they told you what that is, okay? Maybe 6th grade, I don't know. So let's think about this. What are we talking about in this little section? Not just circles, but what about the circles? Yeah, but what have we been talking about so far in the first half of it? Now, we just did a review. We just did a review. We did it in pink. What was it? The segment and the sector. Okay. So that's what's going to come into play here. All right. So let's do this. This isn't actually in the book. I'm just making this up off the top of my head. Let's go right there. What do you think that angle is right there? Give me something somewhere close.
35.
35? That angle's 35.
I would say 45.
What?
40.
Come on. What kind of angle is this? It's an obtuse angle. It can't be 45. It's got to be what? Okay, 110. Thank you. Akira gave me a decent number. 110. It's got to be more than 90, right? It's got to be. No, I'm not doing percent. Okay, I'm not doing percent. I said what angle? The degree measure, I should have said. All right. Everybody settle down. Here we go. So that's 110, right? It's more than 90, right? I don't know if it is exactly 110. Close enough. So what I want to do, I know how to find the area of the whole circle. And give me like a little nice number for a radius. How about 5?
70.
All right. I know I asked you to give me one and I gave you one myself. That's okay. Let's say it's 5. I don't even know what this comes out to be. I'll have to use my calculator, but that's okay. So let's find the area of the whole entire circle. So the area of the whole entire, I'll put circle right there, okay? Area of the circle is, and we'll do it as a decimal. So what am I going to take, what am I going to make pi? 3.14, okay? 0.14. 3.14 times what? 5 squared, good. Okay? So what am I putting in my calculator? Times. You're putting that in your calculator?
25.
Times 25. Thank you. All right. It's one of those days. It seems like every class, it's been a little bit odd today. So 3.14 times 25 is 78.5. Everybody got it? What if it was in, I don't know, give me centimeters, okay? Let's say it's in centimeters. So it's centimeters. Shh, where's everybody going? Hush. So it's centimeters what? Square. All right. So that was easy, right? We did that yesterday. No big deal. But what do you think we're going to do today? We're not going to find the area. Okay, a certain part. What certain part? What have we been talking about? It's the name of the lesson. The sector. Let's find the sector first. We'll eventually do the what after that. The segment. Okay, but right now we're going to do this. Okay, so this, again, it's not the best shading in job ever, but you get the idea. okay? So that's what we want to find the area of right now. Now I kind of wrote over top of that, but that was, what did we say it was? 110. Let's go back to white and put it right here, 110 degrees. So I want to find the area of the sector. I'm going to write the word instead of S because segment and sector start with the same letter, so I'm not just going to put S. So the area of the sector. Now, am I finding the area of the whole entire circle? Is the red the whole entire circle? No. It's how much of the whole entire circle? Part, but give me a number. 110.
Degrees. 110 degrees.
Out of 360. You got it. I was waiting. I knew somebody would say it. It's 110 out of what? What's the whole entire circle? 360. Again, let's go back to an easy one. Shh. I know this is exciting, but you got to contain yourselves, okay? So listen. What if it was 180? How much of a circle is 180? It's half, because why? 180 what? Divided by 360 is 180 divided by 360. 180 divided by 360 is not 2. It's 1/2. It's 1/2. Okay? We talked about this before. There's something in the air today. I don't know. Something weird. Is it just him? I don't know. So look. So 180 over 360 is a half. So half of a circle, we're finding half the area, right? So what if I wanted to find the area of half of the circle? Then I just take that 78.5 and divide it by what? By 2. Okay, or multiply it by 1/2. But that's not what I'm doing. This is not half a circle. How much is it? It's not 180 divided by 360. It's what? It's 110 divided by 360. Does that make sense? Okay. But it's 110 divided by 360, what? Times pi r squared. Pi, in this case, it's what? 5 squared. And now we do that math. Now, because that's the whole entire circle. Yeah, but let's say we're starting from scratch. Okay, or if we're starting from scratch, this is what we're going to do. So, and you're right, we already did find the whole circle. That is the whole circle right there. That's the area of the entire circle, okay? But we're not finding the area of the whole circle. We're finding the area of a piece of the circle, a piece of the pie. That's what the sector is, okay? How much of the pie? 110 degrees out of 360 degrees. You look like you're up to something. No, he looks like he's going to mess with you or something. I don't know. It just looks sneaky. All right. So that's what we're going to do. So we put the numbers in there. I don't know what that is. You could do it any way you want. If you want to do this, watch. You could go pi r squared and get that 78.5. And then what would you do with your calculator? You could do it a couple ways. Watch. Here's a couple ways you could do this. You could go 110 divided by 360, and you'll get something. Let me see what that is. 110 divided by 360. It can't be 39 point anything because, look, it's got to be less than 0. The top is smaller than the bottom. All right? You're just saying stuff. Think before you speak, okay? What it means. So if I do that, I get like 0.30555, and it keeps repeating. All right, and then I could take it and multiply it by 78.5, all right? And I get about 23.98, okay, about 23.98. That's the area of the sector. And it's in, what do we say it was in centimeters? So it's about centimeters squared, okay? I got paper towels. Multiplied it because it's being multiplied, right? So there's a dot for multiplication. Or you could do it like this. You could go 110 times 78.5, take that whole thing and divide that by 360. Would you agree that's the same exact thing? All right. I don't think either way is easier. It's just kind of doing the same thing, kind of. Let's see. All right, so if you wanted, you could go 110 times 78.5. Get an answer for that. It's like 8,668. Then you take that divided by 360, and you actually get a slightly different answer. All right. Again, these are approximations because you got this is an approximation. This is going to be approximation because 78.5 is an approximation, right? Because we had 3.14. So anyway, this actually comes out to 24.07. Let's round it to one place. So look, this one comes out, if I rounded it to the first place, that 8 makes that 9 go up 1, so that turns into a 4. So if I round it to one place, this would have been 24.0. This would have been 24.1. You're like, well, wait a minute, how can I get two different answers for the same thing? Because it depends on how you used your calculator. Like this right there gave you a repeating decimal, okay? And we multiply it by another number, it's going to give you something slightly different than doing it like this, all right, depending on how you use your calculator. It's not much different, is it? But it's slightly different, so you just have to be aware of that. And again, it depends on the book. If they use 3.14, or maybe some places might use use the calculator version of pi. All right, so there is some variability in your answers, but it's not going to be that much different. All right, it's not going to be that much different. So you just have to be careful when you're using your calculator on how you're doing it. All right, so the key to this, it'll probably tell you in the book where to round it. All right, and I'd have to look at the book, but my guess would be that they probably want you to put it in a decimal form and not keep it in terms of pi. Usually for area, that's what they do, okay? So what is the key to this? The key is this thing right there. Out of all the stuff that we just talked about, that thing in that box right there is really important. So to find the sector, what do? You take the angle, right? You divide it by 360, and then you go pi r squared. In fact, the book even writes down a little formula. Here's a little formula for the area of a sector. And we could probably come up with it ourselves. Now, we used 110. Is every single circle and every single sector going to be 110? Of course not. It could be any angle. What do we use for any angle? It's a Greek letter. It's the only Greek letter that you know right now. What is it? Say it. Theta. Okay, did I spell theta for you when I talked about it? Theta is spelled like that, but we say theta. Okay, some people say theta. Tell you the truth, I've never heard anybody say that, but I'm sure somebody says it like that. But I always say theta. So what's the area of the sector? It's not the entire circle, right? It's how much? It's the angle, the central angle, divided by what? 360 times what? The whole circle, which is pi r squared. So if you want to memorize that, you can, I guess. But we kind of figured out what it was before we memorized the formula. Would you agree? Because I said it's just a piece of the pie, right? It's a slice of the pie. How much of a slice? It's 110 degrees out of the whole pizza, out of 360. And then times whatever the area of a circle is, which is pi r squared. So we actually came up with this formula ourselves, didn't we? All right? So that was nice. Look at that, coming up with geometry formulas on our own. How about that? Here's one more. This is the last one. Hopefully we'll be able to finish this. All right, give me a sec. Oops, I don't want a rectangle or square. Let's change this to circle. There we go. All right. Oh, come on. There we go. So there's the, where'd you want to see? There it is right there. Okay? All right. So what we're going to do now, put the center in there. What I'm going to do is this. So we found the area of a sector. What do you think we're going to find now? Area of a segment. It's a little bit more involved. So you guys have been kind of playing around a little bit today. All right, being a little goofy. So I need you to really concentrate on what we're going to do right here. All right, here we go. We'll put some letters in here they do in the book. P, Q, R. They tell you the radius is 3. And they tell you this little P, this PR right there, that one that attaches it, they say that whole thing is 4. Everybody see that? The whole PR is 4. Okay? You got this is 3. So what's PQ going to be? If QR is 3, what's QP going to be?
3.
It's going to be 3. Why? They're both the what? Why? Because they're the what? What word? What name? It's a radius, right? This is the radius. This is the radius. All the radius are equal to each other, right? So if that's 3, what's this have to be? 3. They didn't tell us, but we know that that has to be 3. This is not a radius, is it? All right, they had to tell us that one, all right? And they did. They told us that was 4. What we're trying to do is I'll tell you what, let's put that 4 not here because I'm going to shade in a little bit. Let's put that 4 right there. Is that all right? So now what we're going to do is we want to find the area of the sector. I'm sorry, I lied. I didn't mean sector. What do I mean? Segment. Okay, so watch. We are trying to find this area. Looks like a smiley face, doesn't it? Or a weird, creepy clown smiley face. I don't know. Okay, that's what we're trying to find the area of. Well, first of all, I don't know this angle here, do I? All right. So what can I do? If I can find the whole sector, this kind of goes with what we were talking about earlier when class first started. If I could find the area of the whole sector, which I might be able to do, all right? I can, all right? You might not see it right away, but you can find the area of the whole entire sector because you're going to have to find this angle right here. And we are going to be able to find the angle. Actually, they have to tell you the angle, I believe. Yes, they do tell you the angle. I knew they had to give you that. So that's 40 degrees, that angle right there. So can I find the area of that whole sector? Let's do it right now. Let's forget the segment for just a second. Let's just find the area of the sector. What's our formula for area of the sector? It's the angle divided by 360. So what is it? 40 over 360 pi what? Which is what? What's R? What's the radius? It's 3 and then squared. Okay? Everybody with me on that? So, oh, wait a minute. That's not 40. There's no way that can be 40. Here, I made fun of you guys for saying that one was 40-something when it was an obtuse angle, and here I did the same thing. I just can't read my own writing. That's my problem. It's 84. It's 84 degrees. All right? It looks a little more than 90, but I probably didn't draw it correct. But let's say it's 84. Sorry about that. All right, so what are we going to do? How do I find the area? Plug it into a calculator, right? What's this going to be? 9 times pi, 3.14. Stick it in a calculator. Then multiply it by 84, divide it by 360, and you should get somewhere in the vicinity of approximately 6.6. It's centimeters, like I said, somewhere approximately, okay, in the vicinity. Depends on how you use your calculator. It's going to be somewhere there. This is the sector. This 6.6 is the sector. It's from here to here to here. The whole thing, right. I didn't shade it in, the whole sector, okay? But it is. It's from here to here, all the way around to here, back up to there. All that stuff is 6.6. Got it? But we're just trying to find the red stuff. So what else do you think we may be able to find the area of? The triangle. So if I find the whole entire sector, right, from here to here to here to here, how could I find what's left over? How? Not what the answer is. I already found the whole entire sector. The whole piece of that pie, I found it. Okay? Not just the red, not just the triangle, but the triangle and the red. I found to be 6.6. I want to figure out how to find just the red. Not 4. Take away the... No, not divide. Take away. Take away what? Now say it. The area of the triangle. Not dividing it by the area of the triangle, or taking it away. Yes? So watch. I'm not going to say what I was going to say. Let's just keep going. I only got 1 minute. Oh my gosh. So what I have to do is I got to find the area of the triangle. Once I got 12 minutes? Oh, it's not 20, oh? It's 10 till?
You do this every day.
I do. I'm the worst. How can I not remember? We've only been in school for what, 8 months now or something like that? And I still can't remember what time. Oh my gosh. All right. So we got some time. So let's do this. So look, you got the whole piece of the pie, right? Watch my hands, watch. You got this and this. That's the whole sector. What is it? What's the whole sector? What number? 6.6. 6.6. Now watch. Watch what I'm going to do. It goes from here to here. And then I slice it right there, right? So I got two parts, don't I? I got what? I got the triangle and I got that segment, okay? Now remember, I know what the whole thing is. I know what they both add up to be. Listen, think. You guys are looking around making jokes. Listen and think. You're not thinking. I can tell you're not thinking. Watch. You've got a triangle, you've got the segment, but you know what they both add up to be. What do they both add up to be? 6.6. So how do I find just that little segment? Subtract the what? The triangle from the whole segment, or the whole sector. Okay? So what I want to do, I know the whole thing. I'm not going to shade it in because it'll be too messy. All right? I know the whole thing is 6.6. If I can find the area of the triangle, all I got to do is take it away from the whole piece of the pie, and what do I have left? I got this little sliver right here, which is the segment. And that's how I can find the segment. I don't find it directly, I kind of find it indirectly. Find the whole sector, take away the triangle, what's left? Boom, that red stuff right there. And that's what I want to try to find the area of. So now what do I have to do? What's my work now? I have to find the area of the triangle, exactly. Okay, now I got to find the area of the triangle. Everybody got that? So what are we going to do? We've done this once before, I believe. Can't remember if it was this class or the other class, but I'm going to show you right now. What we're going to do is we're going to take a perpendicular from here to here. Why in the world would I do that? Well, because it's going to help us out, okay? We're going to find the height. That's a great response. I like that answer. Because what is the area of a triangle? It's 1/2 the base times the height. What do I already know about this triangle? The base is 4, that's right. What do I have to find, though? The height, which is the blue one. Okay? You got it? Okay, so let's do this. Let's go off to the side here. You okay with that, if I do that? I'm going to take just one of these triangles off to the side. So that looks like this. Whoops, let's make it look like it's right. It's right. And then let's take this to here. I'm just redrawing it so I don't have all that junk in there. You okay with that? So I know that's a right angle. I know that that's 3. What is this one right here, this bottom, from here to here? What do you think? It's just 2, right? Because the whole thing is 4. If I drop a perpendicular down, it actually makes this into 2 congruent triangles, right? So if I took those triangles and I folded them on top of each other, all the parts would match up. That's called congruent parts, okay? The congruent parts are congruent. Or the corresponding parts, sorry. Corresponding parts are congruent. So watch. This right here and this right here should be equal to each other. All right? So if the whole thing is 4, then that's going to be what? 2. So that's 2. So now what do I have to find? I got to find the height. So look at what we have right here. Let's do Pythagorean theorem. Exactly right. Everybody see that? All right, so let's do Pythagorean theorem. How do I go 2 squared plus 3 squared? No, I go what? H squared plus 2 squared equals 3 squared. Everybody see that? Because there's the A, the B, and the C. So Pythagorean theorem. So we learned Pythagorean theorem so we could use it later on, correct? So now we're using it. That's why it's important to understand all the stuff that you've learned in the past, because it usually comes back and you get to use it again. All right? Let's do the math. What do I get? H squared plus what? 4 equals 9. Subtract 4 from both sides. You can do that in your head. What's that? 5. And then what's H though? H squared, no, we're not taking half of it. This is H squared. It's not 2 times H. It's h squared. Square root. You do the opposite. We've done that in here. Yes? Yep, you square root both sides. So you square root this side. The squared and the squared cancel each other out. You square root this side. So what's h equal to? The square root of 5. I know it's a weird looking number, but it's an actual number. It's a number that works. It's a real number that we can use that can actually be found on a number line. All right? It's an irrational number, which means it comes out to a decimal, and the decimal never repeats itself. Okay? But it is a number. All right? So that's what this is, the square root of 5. And you can put that into a calculator. Your calculator's got a little square root button. You put it in there, boom, square root of 5, and you can get a decimal out of it. Everybody got that? So now, let's do this. What do we do? 1/2 times the base. What did we say the base was? 4. It's not 2. We're talking about the whole entire triangle this time, okay? So it's not just this triangle, it's the whole entire triangle. We just split it up like that to find the height. That's all. That's the only reason we did this. So it's 1/2 times the base times the height. What's the height? Just found it. What is it? Square root of 5. I know that's weird, but with a calculator, it's not that big of a deal. It's pretty easy to do. All right. What's half of 4? It's 2. So this is just 2 square root of 5. And let's put it into a calculator. I got approximately 4.5. Again, because it doesn't come out exact, so you get around 4.5. 1 decimal place is good. We're almost done. Seems like the problem that never ends, doesn't it? So let's do this in another color. All right. So we want to find the area of the segment. The area of the segment. Remember, we spent a lot of time talking about this. The area of the segment is equal to the area of the sector, what? Minus the area of the what? Triangle. Yeah? All right. So now we know the sector. We found that. First thing right off the bat, 6.6. Minus the area of the triangle. What's that? 4.5. Let's put the point down here. 4.5. And now you just do the math and you get what? 2.1. Okay? So it's 2.1. Don't forget your units. I'm not going to carry my units through every single step that I did. I'll just put it at the end. So it's in centimeters, so it's what? Centimeters squared, because it is area. So that red part right there, that red is 2.1. Got it? The triangle is 4.5. The whole sector is 6.6. Yes, sir. You got to do 3 things. Exactly right. You got to memorize 3 formulas. Okay? It's a little bit to memorize for one problem. But look, we're getting to be big kids now. We're not doing little elementary math anymore. The stuff that we're going to do is multiple steps, all right? We just got to get used to that. So let's go through it very briefly. One more time. First, we found the area of the sector, all right? That was what? 84 over 360 times pi r squared. Yes? Right there. Okay, so we found the area of the sector. That's the whole entire thing, right? Now, how do I find the red? Well, I take away the triangle. Okay, how did I find the triangle? 1/2 the base times the height. The base was easy. They already told it to us. We had to do a little bit of work to find the height. A little Pythagorean theorem, boom, found the height. Put it into our triangle formula, we get 4.5. So you got the whole thing, you got the triangle, and what do you do with those 2 things? Subtract them, and now you got what's left over. This segment, the red stuff right there that's shaded in, is the leftover. Okay? Does that make sense? So we don't have a formula just to find the segment. What do you always do to find the segment? You could look at this as your formula. You take the segment. How do you find the segment? You take the whole thing, which is the sector, take away the triangle from it, and you got what's left over. What's left over? It's the segment. What do you think? That was definitely a multi-step problem. All right? Took half my paper right there. All right? But how are you going to remember this? Are you just going to say, well, I sure hope I remember what he talked about in class today? No, you know what you should do, what you won't do, but you should do? Not just study it. No, not even watch the video. I mean, that's eventually you should do that. But the very first thing you should do is go home before you do the homework, All right?
Write down the
Write down this problem, put everything away, put your notes away, do a little studying first, put it away, and then try that problem. All right? Until you do it yourself from scratch, you're not going to know how to do this. I promise you. Everybody understand that? Now, will you do that? Doubt it. All right, I can see it in your eyes. All right, you probably won't. But if you want to know how to do this problem, that's what you should do. I'm telling you what you should do. You can make up your mind and do whatever you want, I guess. All right, but I'm telling you what would be helpful. It would be helpful before you do your homework, just get a blank sheet of paper out and say, look, I'm going to write down what that problem is. That problem's in the book. It's example 3 in the book, okay? So just write it down and then put everything else away and just try it from scratch by memory. See if you can do it. If you were able to do it, then great. Now you can move on to your homework. If not, then you could go to the video and say, oh, what did he do? How did he get that thing? Just slide through the video. You don't have to sit there for 30 minutes and watch my video. Just slide it until you get to that part. Okay, just watch how I do those little steps. Pause it, stop it, write it down. That's how you're supposed to do stuff. It's how you're supposed to do your homework. Okay? Whether or not you do it, it's a different story. So, now you should be able to do 1 to 10 and 13 to 18. So that's, no, it's together. So 1 to 10, wait a minute, 13 to 18, that is your homework, and that is due tomorrow. You've probably done a lot of these already, right? Last night, you might have done some of these. But now you can do the later ones. You should be able to with this. Okay? All right.